In this video, we're going to show how to evaluate definite integrals using geometric formulas, such as formulas for areas of rectangles, circles, trapezoids, and triangles. Let's get started. Let us first talk about the geometric interpretation of a definite integral. Suppose we have here a function f that is continuous on the closed interval ab. For example, let's say that this is the graph of our function f. So how do we evaluate this definite integral here? The integral of f of x dx from a to b. So we may evaluate this integral by using the areas of the regions bounded by the function f and the x-axis on the closed interval a to b. So in this case, we have four regions bounded by the function f and the x-axis. And these are this region, this region, this region, and then this region. And if we know the areas of these regions, let's say that the area of this is A, the area of this region is B, and the area of this region is C, and the area of this region is D, then the value of the definite integral is just equal to, you have here A, and then minus b. If the region is below the x-axis, you have the minus sign there, and then plus c because the region is above the x-axis, and then minus d because the region is below the x-axis, which is the same thing as finding the total area of the regions above the x-axis minus the total area of the regions below the x-axis. So the value of this is called the net signed area on the closed interval AB. And this is the value of this definite integral, integral of f of x dx from a to b. So the value of a definite integral could be positive, could be negative, or zero. If there is more area above the x-axis than below the x-axis, then the definite integral will be positive. But if there is more area below the x-axis than above the x-axis, then in that case, the definite integral will be negative. And if the areas above and areas below are the same, then the definite integral will be equal to 0. Let's have some examples. Suppose this is the graph of our function f here, and we want to evaluate this definite integral, integral from -6 to 0 of f of x dx. Take note that these are congruent triangles, okay? So they have the same area. So if we look at the range of our x values here, so we're integrating from -6 to 0. So we're considering this closed interval here, -6 to 0. So the value of this definite integral is just equal to the area of this region plus the area of this region. And what is the area of this region? This is just a triangle. So we use the formula for area of a triangle, 1/2 base times height. So the base is 3 units, and then the height is 4 units. So the area of this triangle is just equal to 1/2 times 3 times 4, which is equal to 6. Since these two triangles are congruent, the value of this one is just the sum of the areas, which is equal to 6 plus 6, and that is equal to 12. Now, let's evaluate this integral here, this time from x equals -3 to x equals 6. So we have here different limits of integration. So we need to consider x values from x equals -3 to x equals +6. So in this case, we have region above the x-axis and then two regions below the x-axis that are bounded by the function f and the x-axis on this closed interval -3 to 6. So the value of this definite integral is just equal to, again, we know already that the area of this triangle is just equal to a, and that is equal to 6. So of course, the area of this triangle is also equal to 6, and then this one is equal to 6. So the value of the definite integral is just equal to total area of the regions above the x-axis, which is just a, minus the total area of the regions below the x-axis, which is actually equal to 2a. But we can also write that down as minus a and then minus a, because these two triangles here are below the x-axis. Therefore, we obtain negative a, and since a is equal to 6, we have -6 as value of our definite integral. And as you can see, the value of this definite integral is negative because we have more area below the x-axis than above the x-axis. Next problem. So let's evaluate this one here. Integral of f of x dx from -3 to 9. So we are considering this x values here from -3 to -9. So as you can see, we have two regions above the x-axis and also two regions below the x-axis. So based on the graph of f here, what can you say about the value of this definite integral? The value is just equal to 0. And how do we get this 0? Again, if we look at this interval of x values here, then the area of this region is A, and then minus the area of this triangle, and then minus the area of this triangle because this triangle is below the x-axis, and then plus the area of this triangle, which is above the x-axis. So the value of the definite integral is just equal to a minus a minus a, and then plus a, which is equal to 0. So the definite integral is equal to 0 because the total area above the x-axis is the same as the total area below the x-axis. Next problem. So what if we want to evaluate this integral here of f of x dx, this time from x equals -6 to x equals 9. So for this domain of the function f, from x equals -6 to x equals -9. So it is clear from the graph that the value of the definite integral must be positive because we have more area above the x-axis than below the x-axis. And what is the value of the definite integral? It is only equal to the total area of the regions above the x-axis minus the total area of the regions below the x-axis. So this is just equal to 3a minus 2a, which is equal to a, which is equal to 6. Now let's consider a different function. Suppose we want to calculate this definite integral from -3 to +5. So here's the graph of the function f, and it is clear that the function f is what? Non-negative on the closed interval -3 to 5, which means that the value of this is positive. So what is the value of this definite integral? It is just equal to the area of this region bounded by the function f and the x-axis from x equals -3 to x equals 5, which is the area of this trapezoid. What is a trapezoid? It's a quadrilateral with one pair of parallel sides. And do you still remember how to compute for the area of a trapezoid? So if we're given this trapezoid here, the parallel sides are called the bases of this trapezoid. So we can call this base 1 and then base 2. And then this is our altitude or the height. So let's denote it by h. So the area of this trapezoid is just equal to 1/2 times the sum of the bases, the parallel bases, and then times height. So using this formula here, we'll get the value of this definite integral, which is equal to 1/2. These are the parallel sides, so these are the bases. So the length of this base is 8, and then the length of this base is 4. So we have here 8 plus 4, and then times the altitude or the height, and this is the height, which is just equal to 5 minus -3, which is equal to 8. So therefore, the value of the definite integral is just 1/2 times 8 is 4 times 12, which is equal to 48. Now let's consider one more function here. Suppose this is the graph of our function f, and it consists of a semicircle and two straight segments. So now let's compute for the value of this definite integral from -5 to +4. So again, we look at the regions bounded by the function and the x-axis on that closed interval, -5 to 4. So in that case, -5 to 4, so we consider this interval. So we have here a region above the x-axis and region below the x-axis. And the region above the x-axis is just a semicircle. So how do we find the area of this semicircle here? This is just a circle of radius 3. So the area of the semicircle is just 1/2 of the area of a circle with radius 3, which is pi times r squared. So r is equal to 3. Minus the area of this triangle, which is just equal to 1/2 base. So we can consider this as the base, and then the height, which is equal to 4 units. So that is 1/2 times 3 times 4. Therefore, the value of this definite integral is just equal to 9 pi over 2 and then -6. And since pi is greater than 3, so we know that the value of this is positive. Last problem. Suppose we want to calculate this definite integral from -2 to 7. So we want to consider this range of x values from -2 to +7. So we have region above the x-axis and region below the x-axis. So again, we compute for the areas of these regions. So the area of this region here above the x-axis is just what? Area of a quarter of a circle. So we just take 1/4 of the area of the circle, which is just pi times 3 squared. Minus, again, this region here is a trapezoid. Why? Because again, we have these parallel sides. And the height of this one, or altitude, is equal to this one. So the area of this one is just equal to 1/2 times the sum of the bases, the parallel sides, which is what? 7 minus 1, which is equal to 6, plus 3, and then times the height, which is equal to 4. And this is just equal to 1/2 times 4. It is positive 2 times 9, so that is equal to 18. And it is clear from the graph that the value of this is negative, because we have more area below the x-axis than above the x-axis. In case you don't remember the formula for area of a trapezoid, then what you can do for this one is to divide it into two regions, a triangle and a rectangle. And from that, you can already use the area of a triangle and area of a rectangle to compute for the area of this trapezoid.